Hello students, in the previous lecture of industrial automation we have discussed about industrial control circuit, the basics of automation, what is the need of automation, various input and output devices used for automation, and we have discussed the concept that for automation we need to follow certain rules, that each and everything has two things, one input and second is output. In between there something is going to happen that is called as the process. Now if I want to go for the automation, first I need to make it on paper or in the computer. Now, when you're going to do that, we need to use the devices. Say I want to do the automation of a fan. Now, when I have to come, the fan will automatically switch on. When I will go out, the fan will switch off. Or I want to operate the fan on the temperature. So, what you have to do over here, you need to use the temperature sensor if you want to operate the fan on the temperature, or if you want to operate the fan based on the motion of the person, then you have to use the PIR sensor or something. Now when you are going to draw the diagram, you are not going to draw the diagram by using the actual sizes or actual components. What you are going to do, you are not going to draw the symbol of fan, the image of fan or image of regulator. Instead of that we are going for the symbols. Now symbol has one other advantage, that symbols are standardized. If you just design one circuit, okay, so anyone from the world who has the knowledge of electrical engineering can understand the meaning of that circuit because the symbols are globally accepted. Now what are these common symbols which are used in the industrial control circuit? The most widely used symbol is the YNO contact. It is also called as normally open contact. Second one is the NC contact. This is also called as normally closed contact. Okay, YNO contact, in case of PLC it is called as examine if open, and this is examine if closed. Then third thing is the relay coil. Okay, it will show you the output device. That may be a contactor, that may be anything. Okay, so that for that purpose you are going to use the relay coil. Then indicator lamp. Okay, the various indicator lamps are used for giving you the indications whether the system is on or off. Heating element symbol, solenoid coil, then on push button. Okay, so when you are going to press this one, no push button. Okay, so it is normally open type. When you are going to press this, at that time it is going to be closed. So these are normally momentary type. As long as you are going to press it, it will operate. Once you release the pressure, it does not operate. Okay, so this is the NC type. When this button is pressed, the circuit is get disconnected or de-energized. When it is released, the circuit get energized. Then in industry, most commonly used motors are three-phase induction motor. So this is the symbol of motor. Overload, and this is fuse. So these are some symbols. Along with this, there are some other symbols also. For overload, you are going to use this symbol. For NC, in case of PLC ladder diagram, you are going to use this symbol. Okay. For normally open, we are going to use this symbol. Push button. Normally closed type, we are going to use this symbol. Normally open type, this symbol is widely used. Timing close NC. So if you want to just operate a device after certain delay, so you need to use a timer, and the timer NC contact can be represented with this one. Timer close YNO. So this is the symbol for YNO type timer contact. Timing open MC. So it is going to be operated after predetermined time. The circuit is going to be open. Timing open YNO. So it is going to be open after certain time. These are the flow switches contacts. This is normally closed type. This is normally open type. This is limit switch. If you are going to use the limit switch, then the symbol of this one is like this is NC type limit switch. This is NO type limit switch. In case of NO type limit switch, when the limit switch is going to be triggered, at that time the circuit get energized. This is the temperature switch. At a particular temperature, the system is going to be disconnected from the supply, and for this one At particular temperature, the system is going to be connected to the supply. This is the NO type. Pressure switch. It will activate at certain pressure. Pressure switch also has two types, NO type and NC types. Then liquid level. For this one, we are going to use NO type, NC type. This is the commonly used symbol for fuse, coil, circuit breaker, then three-phase motor, indicating lamps, and transformer. Along with that, if you are going to use the iron core type, then this is the adjustable iron core, this is the air core reactor, and this is the magnetic amplifier winding. This is my three-phase induction motor, this is my DC motor. Okay, this is pilot light. Okay, when you are going to press it for testing purpose, this is pilot light to test. This is horn, siren, is commonly used for giving you the audio indications, or during emergency we are going to use this one. Then these are certain symbols which I use. This is the symbol of buzzer and this is the symbol of bell. Now what is control circuit and what is power circuit? Control circuit requires control supply, and control supply is nothing but a separate power supply to operate or control the power circuits using control circuits. Control circuit is basically operated at reduced voltage. Normally you are going to use DC voltage, that may be 5 volt, 12 volt or 24 volt, or if it is AC voltage, the AC volt may be 110 volt or 230 volt. And power circuit or power supply normally consists of 230 volts onwards single phase, and if it is a three phase, this is 400 volt, 600 volt or anything. Then control circuit means the auxiliary circuit which is made with the contactor, NO and NC switches, protecting relay, MCB, etc. In starter, if you are going to take the example of the control circuit, in a starter, that may be a dual starter or star delta starter, we use contactor. When the contactor holds the power, goes to the load. When to hold the contactor, we have to give a electric supply to the contactor coil. That supply is called as control supply. The control supply voltage level depends on the contactor coil. Typically 440 volt use in agriculture starter, 230 volt use in industrial DOL or star delta starter, 110 volt is used in heavy hoist and crane application, 24 volt use in PLC and DCS control system, 5 volt use in microprocessor electronic equipment. So these are the various control voltages. Now what is control circuit and power circuit? So in case of power circuit, we are normally connecting the three phases, that is 400 volt supply or 415 volt supply directly to the motor. In power circuit, we are going to use circuit breakers, fuse, overload protection, okay, and contactor. So this is your circuit breaker, that may be MCCB, overload protection, that may be thermal bimetallic relay, and this is your contactor coils. Now this is your power circuit in which the voltage level is high, but if person will directly operate this power circuit, then there may be a chances of injury or electric shock. So to protect, what you are going to do, we are going to operate this system with the help of reduced voltage. For that purpose, you are going to use the control circuit. So this is the typical control circuit for dual starter. Now in control circuit, we have push button, start push button, stop push button. Okay, so these push button which are used in the control circuits are normally press and release type. We are not going to recommend press and hold type over here. So once the button is pressed, as long as you are going to press it, the button will get energized. Once you are released, the button get de-energized. So what happen? When the start button is pressed, at that time the current will flow from P to start, start to stop, stop to NC, NC to contactor coil, and contactor coil to new. So the path of the current will complete. When you are going to release this, okay, so as the contactor coil get energized, this is the auxiliary contact of the contactor coil. So once the contactor energized and after releasing the start push button, the current will flow from P to NO contact to start push button, start to NC, NC to contactor coil, and this one. This supply path remains continuous as long as the stop push button is not pressed. Once you are press the stop push button, the circuit is going to be open, the contactor coil get de-energized. Once that contactor coil get de-energized, this NO contact will again open and disconnect your circuit. So this is also called as a three-wire protection. There are two types of circuit that we are going to discuss later on. Okay, so this is typically a power circuit and this is typically a control circuit. Now in power wiring is used for connecting load to main power supply through appropriate switchgears and protective devices such as overload relay contacts. Control wiring used for connecting control circuit which consist of input devices such as push button, selector switch, proximity switches, indicating lamp, etc. In power wiring is connected between main supply and load, and control wiring is connected between secondary of the control transformer. For power wiring we are going to use high voltage, for control wiring we are going to use less voltage. Power wiring, it is at main supply voltage level, that is 440 volt and above, and control wiring may be low voltage, that may be DC voltage or that may be AC voltage. If it is DC, then it may be 5 volt, 6 volt, 9 volt, 12 volt, 24 volt DC, and if it is AC, that may be 110 volt AC or 230 volt AC. A power wiring, a conductor selection of power wiring is based on the rating of the load and overload capacity. For control wiring, the conductor with small current capacity can be used for connecting control circuit, as control circuit does not carry higher current. Okay, so basically in power wiring, the conductor that we are going to select based on the load. Okay, if the load increases, the size of conductor also increases. Okay, for 5 HP motor, the conductor may be different. For 15 HP motor, the conductor size may be different. But for the control wiring, the conductor size is irrespective of the load. Then for control circuit and power circuit, again we are going to discuss two things: two wire control and three wire control. Basically what happens in two wire control, we are going to use press and hold type switches. But when you are going to use the press and hold type switches, the security or the safety related issue will arise. Say, take an example. If a person is operating a saw machine, okay, in which he is going to cut the wood. So what happened? The person is cutting a wooden block. Because of certain reason, there may be power cut. Okay, and the machine will stop. What happened? The person is going to be, the operator is going to be relaxed. He has put his hand over there and he is going to just discuss with his friend or something. Suddenly the power will restore. So what happened? When the power will restore, the machine will automatically start, and that may result into the injury of the operator. So in industry we are not going to recommend the two wire control. Instead of that, we are going to recommend the three wire control. In three wire control, we are going to use the contactor. So in case of the power failure, the machine will stop. But when the power is restored, the machine does not start by itself. Unless and until the operator will press the start button, the machine does not start. So safety is the major concern, and for that purpose, we are going to recommend the three wire control over there. So now we are going to discuss. In two-wire control, the control component offers only two wires for its connection in control circuit. And in three-wire control, the control component offers three wires for their connection in control circuit. In two-wire, the control device is usually a switch, maybe automatic switch such as limit switch, float switch, or anything. In three-wire, the control components are usually push button, and these push buttons are press and release type. In two-wire control, on supply failure the motor stop, but when it's restored the motor start automatically without starter and may get damaged. Thus the motor is not protected from no load condition, as well as it may causes the injury to the operator. But in three wire case, on supply failure the motor stop, and when the supply is restored the motor does not start automatically. The operator need to start the motor using the starter. The safe starting ensure no hold protection. So this is basically a two wire. In two wire there are only two wires. So this is a automatically operated switch. This may be a pressure operated switch. So when certain pressure arises, the switch is closed and open. and in this case we are going to use the 3 wire. So it is my first wire, the stop button and start button. Okay, so if the supply the system will start only when the start button is pressed. Okay, so if power cut will occur, at that time the machine will disconnect it and it will not start again unless and until the start button is pressed. So these are the advantages of your start push button.